Anjali Venkateshwaran, and it is my pleasure to introduce Valeriia Syrovatska, who will be joining me today. Valeriia is a scientist at Biomere site in Worcester, Massachusetts, and she focuses on developing flow cytometry panels. Valeriia received her bachelor's degree from the Massachusetts College of Pharmacy and Health Sciences and her master's degree from Brown University. Joine Biomere is a preclinical CRO with locations in Worcester, Massachusetts, Richmond, California, and multiple sites in China. The company's portfolio includes comprehensive discovery, ADME, and GLP toxicology services. You can learn more about Biomere's service offering at www.biomere.com. So let's get into today's topic on preclinical flow cytometry services at Biomere. Welcome, Valeriia. How are you?
Hi, Anjali. Thank you so much for introducing me. I'm doing great. How are you?
Doing well. So let's get right into it. Let's start with an overview on Biomere's growing capabilities in the flow type cytometry space. Definitely an exciting space. So let's talk more about, what you and the flow group are up to.
Sure. So just a preface, flow cytometry is a powerful analytical assay that uses fluorescently conjugated antibodies to track surface and intracellular targets. Most common applications of flow cytometry at Biomere are immune profiling and receptor occupancy.
Got it. Got it. And so we'll go more into, maybe we'll talk a little bit on immune cell profiling and, because I think that's an area that's kind of become really important, especially in immune oncology, autoimmune disease. So tell us a little bit more. What kind of like studies do you do? I'm sure they run a range, but do you have, are there some studies that are more common than others?
Yeah, absolutely. Majority of our studies are immune profiling, like you said. Recently, some of the most frequent studies we've been doing are LNP delivered therapies and other drug-based treatments. So we're looking at tracking inflammation, cellular uptake, off-target effects, and flow cytometry is great for that because of the versatility it brings.
So essentially, what I understand is you've got your control samples, and then you have your LNP treated samples, and then you look at changes in immune cell population mix. Are you seeing an uptick in, oh, I don't know, NK cells or a macrophage, M2 macrophages or something like that? Is that kind of what you guys are doing?
Right. We definitely start with pre-dose samples and we look at how the animal's immune system looked before any therapies were administered. And then usually we look at a few time points throughout the study to sort of track the progression of the response the animals have to therapies. So yes, we're looking at, depending on the study, it could be T cell or B cell depletion or activation of certain markers, or even receptor occupancy. So whether the target made it to the tissue that it had to get to.
And that's super important, right? Because if it's like an antibody study or something that binds a cell surface receptor, you want to make sure that there is target engagement, so to
Right.
speak. Okay, got it. So we talked about the samples. So kind of what's the main sources of the samples? In other words, what are the tissue types and species that you work with primarily?
So, like, at Biomere, we work with variety of small animal and large animal species. However, for flow cytometry, recently, majority of the studies focused on non-human primates. In terms of the samples and tissue types that we get, the main requirement is for it to be a single cell suspension. And the most common sample we get is blood, of course, because that's something that can be taken at many time points. It's not an invasive procedure, so it can be used for longitudinal studies or even the fast ones. So blood would be the most frequent one. However, we also see a lot of bone marrow, and even tissues like spleen and lymph nodes.
So for those tissues, and that was what I was thinking, so things like spleen and lymph nodes, you would have to basically do some mechanical disassociation to make the single cell suspension, right?
Right. Yeah.
So, okay. Okay. But with peripheral blood, those are probably easy to process and kind of just handle. And
Yeah.
tell me a little bit about, yeah, and tell me a little bit about the volumes, because when I think mouse and I think NHP, the first thing that pops in my head is, gosh, the sample volumes must be really different between a small animal and large animal. So
Yes.
tell me more
Uh,
about that.
that honestly could be one of the reasons why we're seeing more NHP studies than small animal studies. Although our instrument can accommodate smaller sample sizes, we still require a good amount of cells in order to see population spread. I would say for the smaller side of the panel, we're looking at least 1 milliliter of blood, and that would give
Mm.
us anywhere between 1 million and 3 million cells. Ideally, we would want a little more if we have a larger panel so we can accommodate all the controls, all the FMOs, and anything that we need, and also allow for a good amount of events to register for samples themselves.
Sorry, I'm going to show my ignorance. FMO.
Sorry, I should have explained. FMO is a fluorescence minus one. So we have
Okay.
different types of control in flow cytometry. One of those
Yeah.
is fluorescence minus one. So basically, what it is we add all the stains in the panel except one, and that allows us to clearly gate out and define the population that is missing. Another type of control that we use is a single stain control, which is sort of the opposite of that.
Right. No, that makes sense. One's kind of like a negative and one's kind of a positive. That makes
Right.
sense. Oh, that's really cool. So speaking of instrumentation, I know the Biomere has a really kind of cool flow cytometer, which is a Cytoflex LX. So tell me more about that. And is that your workhorse instrument? And is that what you guys primarily use for all your studies?
Yes, that is the instrument that we use for all of our studies, actually. It has 5 lasers. It is very comprehensive. It can accommodate up to 21 colors.
Wow.
However, we like to keep it under 12 to 15 in order to make sure that we can produce good quality data with good spread out on the compensation. So, yes, it is very versatile. It is very sensitive too, so we can look into those smaller populations that clients are currently looking at.
Got it. Got it. And it's pretty reliable and basically you get data pretty quickly, don't you?
Yes, we get data very quickly. Clients can expect raw files within 24 hours and analyze data within 2 to 3 days, ideally, depending on the complexity of the panel that needs to be analyzed.
And I think that's really an important thing to point out. So I just want to pause here because, one of the things I think is when, clients, biopharma drug developers are sending their precious drugs, whether it's LNP vaccines, whatever therapeutic, this is the most important thing to them. So I think the fact that they get the data back so quickly must be really, really encouraging and very positive because I think what I feel is what biopharma clients don't like is the black box approach where they don't quite know they're sending their drug, the therapeutic or a few candidates or whatever it is they're outsourcing that and hoping and praying things look good and then after a good amount of time passes they get some data back but the fact that and that can be very unnerving, right, if you're really depending on
Yeah,
key data, but the fact that you and your team flip the data around so quickly is amazing. That's as close to real-time data as sharing as possible because did you say to raw data in 24 hours and analyze data
yes,
in 2 to 3 business days? That's amazing. I think that's something really noteworthy because flow data, from what I've seen, is often used to make a lot of decisions, go, no go decisions, dosing decisions, and it's really, really informative, right? So that's
absolutely.
I think really amazing. So I wanted to kind of you mentioned something earlier about doing, you can handle up to 12 to 15 colors. That's amazing. But I'm gonna be a little like I'm gonna poke you a little bit and ask in terms of, a lot of the flow cytometry assays, right? They depend on the antibodies.
Of course.
If you don't have the antibody, you really can't run, flow unless you perhaps use like some kind of stain or something. And you mentioned that I know the Biome has a lot of experience running primate studies. This is you guys are really really good at that. So it would be and you mentioned that most of the studies are samples are from NHPs. But tell me something. There's not many NHP specific antibodies out there, right? So how do you guys do the antibody? How do you guys manage to match antibodies that work in NHP samples?
That's actually a great question. So, with the growing popularity of NHP studies, there have been a decent amount of NHP specific antibodies popping up on the market. However, if the client is interested in a target that is not necessarily validated for NHP use, we would work with them to do literature review and dig through the internet to find an antibody that has been reported to cross-react with NHPs, which most often that would be human antibodies that
Yeah,
cross-react.
yeah.
So we would select a couple of those, and then prior to every study, absolutely necessarily, we would run a test run where we would test the panel to make sure sensitivity and reactivity is optimal. And that sets us up for success for the downstream studies time points.
And based on some of the work, the panels that you've developed, some of the work you've done, I'm guessing you primarily use monoclonal antibodies, or do you use any
Yes.
polyclonals?
We use both, but monoclonal are usually cleaner.
Yeah, yeah.
Yeah.
And I think, I was thinking back of some of the large catalogs of a lot of antibody companies. The good thing is for a given target, sometimes you have more than one monoclonal.
Yeah,
So if the sequence between a human and NHP, may not work for a specific part of that protein target, you could perhaps try other clones. So I think there's some
for sure.
opportunity there to do some kind of searches and testing and stuff like that. So that's interesting that it's what I'm hearing you say is that the antibody availability is not necessarily a kind of a bottleneck. You can
Yeah,
find a way around it.
we can definitely find a way around it. And we work closely with clients throughout the study. If something is not working for them, if the clone is not exhibiting enough signal, enough for their purposes,
Yeah.
we pivot, we adjust, we switch things around. And that's how it is. We try to keep study design adaptive because we know how important it is for clients to get the results that they're looking for.
No, that's awesome. And I think that kind of embodies, the whole Biomere concept of it's being personal and being nimble. And I think that's really, really important, right? Because multiplex flow is incredibly powerful if the panel is designed correctly, as you said, and you have the right kind of signal, and you don't have, crazy high or crazy low signals that can, kind of confuse and confound data analysis. So, one thing that's I've heard being coming up quite a bit is that, oh man, NHP studies are expensive, and especially, drug developers can be on preclinical drug developers can be on a limited budget where, they don't have too much money to spend. So I think it would be a fair statement to say that sometimes drug developers have legitimate concerns like, oh man, how expensive is this going to be? What am I really getting out of it, right? Because if you're spending a good chunk of money to run an NHP study and flow being one of them. So kind of tell me a little bit more about, when somebody commits to doing flow cytometry or, say immune profiling in an NHP study, what kind of a data package do they get? I know we've touched upon this a little bit in terms of, longitudinal testing, but it'll be really good. I kind of understand what a typical study would look like, with the caveat that there are always exceptions in study design. What's a typical study look like?
Yeah, so you're definitely right. Flow cytometry can get a little pricey.
Yeah.
However, because of the amount of stuff we can track with it, it is usually very worth it. And honestly, a lot of the studies base their entire design on flow cytometry because of how many things it can show them. It
Okay.
considers immune system dynamics. It can track activation and suppression in real time, essentially, because of how fast the data is generated. So they see the progression of their therapy as it happens, essentially. So because of how much we can get from that data, it is often worth for clients.
So I'm going to ask you a little bit of a kind of going into the weeds question. So
Mhm.
what's the shortest time frame, right? Because you've got your animals on study, you do your dose. How what's the shortest time frame between dosing and sample collection, have you analyzed? Because you said it's fast, right? Especially like a receptor
Yeah.
occupancy, does it go and bind fast? What's the shortest time frame?
Yes, so some therapies are designed to act fast, like
Yeah.
LNPs can produce a response as fast as an hour from my experience, maybe faster.
Wow.
But
Yeah.
for flow, samples can be collected um, an hour, 6 hour time point, 24 hour. Honestly, as many time points as the client wants to look at, will analyze. But an hour is the shortest I've seen.
Yeah, that's quick. That is
Yeah.
like really, really quick because if you're doing a systemic administration, it's going to take some time to get to the things are going to take a little bit of time, but that's really interesting because in my mind that adds a lot of value because you're getting this really fast. You can do time points, you can do long time points, you can trend time points. So I think there is a lot of value. And you said something interesting where a lot of flow cytometry data is used to make go, no go decisions because it
Oh, yeah.
provides so much info. And but tell me something, coming back, you mentioned about the speed of the data analysis, but I mean, from say you do a 15 color panel, right? And you've got, I'm making this up here, say like 4 time points. That's a lot of data. How
Yeah.
do you guys analyze it? Do you have any tools that you use, any software, or how do you guys typically, analyze and kind of annotate the raw data?
Yes, absolutely. We use Flojo, which is the most commonly used flow cytometry analysis software. We use it to gate, sometimes tweak compensation, and create tables. But majority of the data is presented to the client in Excel-based data summaries.
Got it. And since you've done so many of these, you're probably super quick at analyzing them, huh?
I'm
Like
pretty quick.
you've done this enough number of times where you can speed through then. And I think there's some value there, right? Because if somebody does flow, I can, speak for myself. And I used to back in the days when I would do flow occasionally. So it wasn't a routine thing. So data analysis would take time because it wasn't something I did on a relatively frequent basis. But if you're used to it and you know how to work within Flojo or just what you're looking for, what kind of raw data comes off of the machine. I think it's speed, your speed goes up considerably.
Yes, 100%. And when you have multiple time points, you have already established your gating strategy. So it gets even easier because you already see the populations. You can track where they move and really present the data in a whole context.
No, that makes a ton of sense. So I want to switch gears because this is something, that you hear about a lot and you read about a lot is, data from NHP studies, right? Now I know NHPs are expensive and there's a lot of issues with that, but they're super, super translational, right?
Yes.
And especially whether you're looking at the immune system, you're looking at so many different disease areas. I know neuroscience, but as well, but you know, when I think of NHP studies using flow, I mean, that's like probably at the highest end of translational, right? Because NHPs translate beautifully to humans, and flow cytometry is definitely a method that translates beautifully from preclinical to clinical. However, though, I think, depending on the kind of study or what the scientific question, I'm sure there are, your clients come to you saying, "Oh, I'd like to test this thing and that thing," and then they want to have their favorite markers. So how do you address, this request for I want the sun, moon, and stars in a custom panel? How do you guys approach custom panels?
So majority of our clients actually work with custom panels. So
Oh, okay.
before the study even gets on the paper, we sit down with them and we try to understand what they want to get out of it. And once we know their goals, we can suggest the markers that would be most important to get there. And then if we have more room, we will add more specificity. If they would like to dig deeper into those populations, we can definitely accommodate that. Um, and that really brings the value of the custom approach because um, you don't always need an entire immune panel. Sometimes you just want to look at depletion of one particular antigen.
Yeah. And I'm assuming that since you've done so many different types of studies, you have a database of which antibodies, which markers are the most informative, A, which markers are more informative, and B, which antibodies work best in a panel. So basically, your clients are you're able to access all that expertise and historical data by when they're developing custom panels. For example, if they came to you with a marker and you're like, you know what, that might be a trouble because there's really no good antibody for it, or something like that, you can share that expertise, which is kind of really powerful, I think.
Yes, you actually bring up a very interesting point. Although there are multitude of antibodies commercially available, for some reason, a lot of them don't react. And maybe it's just a sample type or donor variability, we don't know. But yes, we do keep a database of antibodies that have worked for us in the past. And that comes in play, bringing a very valuable input because we don't have to test 5 antibodies at every test run, prior to every study. We can look through our database and we can select the markers and clones that would work best for the species that the study targets. And like you said, if the antibody is absolutely not available for this particular target for this species, there are even options for
Yes,
getting antibodies made specifically for a target of interest.
true. Which is really true. And I think, I believe that value cannot be understated because you're right. When you look at the antibody catalogs of many different companies, many of them say flow, but are they truly validated? Have they truly
Right.
been tested? And again, yes, probably in human. How do we know to react in NHPs? And you're right, even though an antibody theoretically works for flow, maybe it's not that sensitive,
Yeah.
or it's not that specific, so you get a little bit of messy, noisy data and things like that. So I think the fact that you guys have got this database, this historical knowledge, for like common immune cell markers and things like that, I think that's extremely, extremely valuable. And in the bargain, I think it actually ends up being a cost savings and time savings for
Definitely.
clients because we're not trying to as you said, test 5 different clones, which is expensive. Let's face it, it's not, and it's so. I think that's a real value of outsourcing flow cytometry. Because you're tapping into expertise from the community, the ecosystem of people who do flow. That's really cool. So, you mentioned LNPs and things like that. So right now, as you guys are doing more and more studies, you probably see the gamut of, therapeutic modalities. So what are you seeing more come through? Is it primarily LNPs? Is it also some, conventional monoclonal antibodies? What's your mix look like?
So actually, LNPs have been on our radar a lot more lately, and
Okay.
that is the main thing we're testing right now. Of course, together with other drug-based therapies, but yes, LNPs are on the forefront.
Interesting. So the idea is, I see. So you dose the LNPs, then you look for immune cell profiling and trying to see how whatever the payload of the LNP is. Have you guys done any vaccine work in the past, or is there something that Biomere is interested in doing?
I personally haven't done that at Biomere, but I do believe that there have been vaccine studies, and we recently actually got a couple of requests for vaccine work. Of course, I can't go into details right now, but yes, we can support a variety of modalities, ranging from um, conventional therapies to small molecules to, of course, vaccines and LNPs.
And then that's awesome because again, as I think, as the modalities get more and more complex, right? I see flow being this multiplex flow concept, I should clarify. The multiplex flow being so valuable in giving a kind of a holistic global view of changes, right? So you're not just looking at zeroing in on one marker and kind of ignoring what else is happening. So I think there's so much translational value. And I do believe that, more and more we'll see flow cytometry panels popping up in clinical studies where they can be used to monitor disease progression and therapeutic response and things like that. So the work that you're doing preclinically, in NHP samples, I think that can directly translate into humans, and that's a huge amount of value.
Yes, I definitely agree. And I honestly see flow as more of a tool to maintain continuity between preclinical and clinical studies, because especially with NHP work, those monitoring strategies can serve as a blueprint for the downstream plans. So even if we can't take this exact panel, we can adapt the panel to look at the same targets.
Yes. No, I completely agree. And coming back to what you said earlier, if you have like human antibodies that work beautifully in NHPs, you could theoretically use the exact same antibody whether you're
Exactly.
testing NHP samples or patient samples, which I think is marvelous. I mean, there's a lot we can talk about how, the lack of translational value can put a real is one of the reasons that there's such a drop off from preclinical to clinical of drugs of drug movement, from preclinical to
Yeah,
clinical. So marvelous. Well, I'm going to say, I think this has been wonderful. I really enjoyed talking to you, Valeriia.
I
Thank you
really did.
so much for sharing the information. This is so exciting. And I'm so glad that, you and your team are working and developing more custom panels and developing a solid expertise in this space. I think that's going to be of high value to the biopharma community, especially folks who are focusing on using NHPs as their preclinical models. So yeah, and the translational potential we talked about. So I think this is really exciting stuff. So preclinical flow cytometry studies in NHPs, that's the gateway to the clinic, I think.
100%. 100%. Thank you so much, Anjali. I really enjoyed talking with you today as well.
Likewise. And if so, for our viewers, if you're interested in learning more, email bd@biomere.com or check out the Biomere website, www.biomere.com. Thank you.